part 8.5 sort 5-element array using the minimum number of comparisons for the worst case. So that's the whole question. All right. This is a very difficult question. Very difficult. You can try. Before you watch this video, you can try, if you like, if you have enough time, you can try by yourself first, at least 10 minutes first. Yeah. Then look at the, very smart solution. So not very complicated. If you find the right way, not very complicated. All right, so let me start the solution first. Yeah. But the first time, I do not just give you the best solution. The first time I want to try our old method and see how well we can do. Definitely we won't get the best solution. Then next round, we try to get the best solution. We need to tweak the first solution a little bit and get the best solution. Yeah, so I take that approach. All right. All right, first. The first way, here, I still use, suppose we are given 5 elements, okay, or 5 distinct elements. Okay, I still use x0, x1, x2, x3, and x4. All right, yeah. If we just use our method to sort 4-element array, remember, how did we solve the 4-element array problem? Remember that. Insertion with binary search, right? Insertion with binary. Let's try use that way and see how many comparisons do we need for the worst case. All right. Using the same idea, first, we just sort the first 4 elements. Because we did that before, right? We do not need to repeat it. We just use our old result, then we insert a new element, all right? Yeah. When we use the old result, we need 5 comparisons, right? Remember? 5 comparisons, okay? Now, in order to insert a new one, right? But here you can see, even we use the binary search, there are 4 elements to be inserted into it. 4 elements, it is an even number, 4. Which one is the median, right? Yeah. So actually, based on the definition, there is a left median. This is the left median, and another right median. 2 medians. Okay, yeah. Sometimes people define the median average of these 2, but here, because we want our median is the element right in this array, so we cannot define our median as the average of left median, right median. We cannot. So we have to select one of the 2 medians. So the default median, we always use the left median as the default median. Okay? All right, so that's the background. Now, if you compare x4 with the median x1 for the worst case, remember for the worst case, then x4 is greater x1. That will be worse. That will be worse. x4 greater than x1. So we need to look into these 2 elements. Okay, these 2 elements. And you need 2 more comparisons, right? Yeah. So here you can see, actually you need 3 comparisons. 1 here, 1 here, and 1 here. So 3 more comparisons. Then combine these 2 steps, total 8 comparisons. All right? 8 comparisons. All right. That's the way we use our old solution. But I can tell you this is not the best solution. Okay? The best solution is best 7 comparisons. 7 comparisons to sort any given 5-element array for the worst case. For the worst case, you can always sort any given 5-element array for the worst case. Okay. You can try, So here, I tell you the goal, get 7 comparisons. But if you try, it is very easy to spend several hours, but you cannot make it in 7 comparisons. That hard, really hard. All right, but here, I just tell you several key steps. If you get those key steps, then you can get 7 comparisons. Not that hard. All right. Here, first, the problem. Why this solution not good? So first we want to know why not good. We need to know the reason why it is not good, right? Then we know how to improve it. Then we have some idea how to improve it. And we can do some tweaking, okay? But still, you need to use your experience. Experience here is extremely important. All right. So why it is not good? All right. So it happens at this 5 comparisons. It happens in this 5 comparisons. Okay. Our first assumption. What is our first assumption? We use 5 comparisons to sort the first 4 elements. Right? So this is our, first assumption. Okay? The problem is here. Okay? Right here. Okay? So what kind of problem? We are too generous here. The problem is we're too generous. We're too generous here. So that means if we use 5 comparisons, we can do more than this. Sorting first 4 elements. We can do more than this. But we didn't. We waste a little bit. We list partial information from our first 5 comparisons. Our first 5 comparisons, we can do a little more than just sorting the first 4 elements. That's the problem. When we do tweaking, we want to squeeze out a little more information than just sorting the first 4 elements. That's the point. But this kind of very deep understanding, if you do not have a lot of experience, it is very hard to get it. We can do more than this, or we can get more information than what we have here. That's the point. All right, so let me use, but I guess at this point, many of you may not feel easy to understand this point. What I said. You may not get a good understanding on it. So in this slide, I want to explain. I want to let you see the point, the main point. The main point I give you in the previous slide. So we can squeeze out a little more information here. Okay, so we need to squeeze out a little more info from our comparison. But here I want to use 3 comparisons as an example to show you the point. Example, yeah. To show you the point. Yeah, because 3 comparisons, relatively small number, so just show you the point. Okay, all right. Here, how much we can do using 3 comparisons? Think about this. How much can we do just using 3 comparisons? Okay, my statement. We can sort first 3 elements. Do you agree with that? We can sort first 3 elements using 3 comparisons. Do you agree with that? The answer is true, but not good enough. Although the statement is true, the claim is true, because we can do more than this. More means more info. We can get more info than just this information here. Okay? 3 comparisons, we can get more information. We can squeeze out more information than just this much. Okay? This much information. Let me show you why and how to squeeze more. Okay? How to squeeze more. All right, very simple. Before I do comparison, I group them in this way. X0, X1, and they do comparison. X2 and X3, they do comparison. Okay? So one comparison here, one comparison here, right? All right. Suppose I assume X1 is the winner. Okay? Suppose I assume X3 is the winner. Okay? Otherwise, we just, switch. Yeah. Swap. Okay? Yeah. All right. My third comparison, I want to compare X1 and X3, so I need a third. Oh, what's that? So I need third comparison, right? Yeah. So you can see, suppose X1 is the winner. How about that? X1 is the winner. Okay. All right. So now look at this. Look at this. Here we just use 3 comparisons, right? Yeah. 3 comparisons. Yeah. Same as the one we use here, but look at here. How much information we get? We get more than before. Right? The information we get, all right, first we get a sorted 3-element array in this way. X2 less than X3 less than X1, right? Do we get this? X2 less than X3 from this comparison, X3 less than X1 from that comparison. But at the same time, we get X0 also less than X1. How about that? Okay, you see, other than this 3 element get sorted, we get another extra piece of information here. Okay, so that's what I mean. We can squeeze out a little more. This piece of information may help us to get the best solution, to reduce the number of comparisons from 8 to 7. So this piece is critical. Okay? All right. So our last slide, I want to use this idea to give you 7 comparison solution. 7 comparison solution. All right, so the last step. Now, the first three we do same as before. Okay, yeah. First three compare 0, 1, x1 is the winner. Okay, 2, 3, x3 is the winner. All right, so then let me just use x3 as the winner. All right, yeah. So after 3 comparisons, 1 here, 1 here, 1 here, total 3 comparison, we get this much information. All right, so now, in order to write fewer number of words, I want to use diagram to explain my idea. Otherwise, I need to write too many words. Okay, all right. Here, I draw the diagram. Okay, all right. Because x3, this dot x3 is greater than what? x1. Okay, is greater than x1, right? Yeah, x1. And x1 is greater than x0. Okay, all right. But we also know another piece of information. x3 is greater than x2. Okay, that's the current information we have. All right. Now we want to consider x4. We want to insert x4 somewhere in this tree. Okay, in this tree. Okay, all right. When we do the insertion, our comparison, the best comparison, you can see we should compare x4 with the one in the middle, in this longest branch, but the middle element in the longest branch of the tree. Okay, all right. So when you do the comparison with that, there are 2 cases: greater than x1, less than x1. Right? Greater than x1, less than x1. Okay? Yeah. All right. Suppose greater than x1. So let's draw the first case. Greater than x1. Yeah. x4. Greater than x1. Okay? Then, so this is comparison number 4. Number 4. Then, can we compare with x3? x3 and x4, greater than, less than, 2 cases, right? All right, so we consider greater than, less than, 2 cases. Yeah. Greater than, then we have x4, x3, x1, this longest branch, right? x0, then x2. Okay? Yeah. All right, so this is the comparison number 5. All right? Yeah. Then you can see, in order to put x2 in the already sorted array, we know x2 less than x4 and x3. We only need to compare with x1 and x0. So 2 more comparison. 2 more. Okay? Number 5, 2 more. 7, right? Yeah, so this case we get 7 comparison. All right. But that's one case. Another case. Okay? Another case. Yeah. Another case. x3 greater than x4. All right? Greater than x1. Yeah. So let me put it here. x1 greater than x0. But now x2 is here, right? Yeah. In order to insert x2 into the sorted array, we only need to consider these 3, but we compare it in the middle. 1, no matter greater or less, just 1 more is enough. Okay? Yeah, 1 more is enough. So that means in this case, also need 2 more. 2 more. Okay? All right. So that's the okay. Then, because there is another case we need to consider. Yeah. So that's why it is complicated. So x3, x2, all right, yeah. x1, x0, x4, right? Yeah. Then we need another comparison. So number 5 here. So we get this x3, x2, x1. You know, here no matter x0 here or x4, it's not that important, right? Yeah, because there is another case we switch these two. It's not that important. Any cases we just need 2 more. One in the middle, then based on less than greater another one, so 2 more. So you can see you put together the total answer 7 comparisons here. See, all right. So try to see if you can follow. You know, yeah. Here I draw the diagram. Try to understand if you can follow all these steps. All these steps. Yeah. So you can write a little more. Yeah. Here on my side, yeah, to save time, I didn't write a lot of words. Yeah. All right. So that's the, you know, whole solution. Yeah. And we finish 8.5 video and also part A. Yeah. All right. So let me